We'd like to begin our presentation by saying thank you so much for reviewing the work that was accomplished as part of the CS410 Text Information Systems course. This is the final project work by Megan Massans and Cynthia Johnson. Our goal was to provide a web application that would enable patent searches across an organization. Researchers doing very innovative work require a proprietary application to perform their searches. Since their searches need to be protected, the use of Google or Google patents or other open source applications are not allowed within our organization. This tool will be given directly to the users, the researchers performing these tasks. Currently, specialists perform their searches for them and provide them the results. During our presentation, we'd like to provide an application overview, discuss how to install the software, how to use the software, and then provide a use case example on how to test the software. We'll begin with an architecture overview. CSV files were uploaded from the patentsview.org website. Going there, we can actually see that there's actually over 6 million records of patent data in CSV files. This information is loaded into a SQL Server database along with information pertaining to the location and other companies. This information is then placed into Azure Search for indexing. User information and search history are placed into a SQLite database. Within the Python environment, we use WT forms and Jinja2 templates to enable rapid application development. We also took advantage of validators within WT forms. We used SQL Alchemy as our ORM for a SQLite database. We used NLTK to perform bag of words on patent titles, as well as GenSim to do topic modeling on patent abstracts. Patent title bag of words was placed into D3 extensions to show a word cloud of the patent titles. This application is housed within the Azure environment. Because of that, there's actually no need to install the application. But before we begin to go through the install, I'd actually like to take a brief moment to go over to the application. This application is housed within Azure. You can see a refresh for me happens very rapidly. Your initial load should take up to 15 seconds to cache all of the libraries that are used within this application. So don't be surprised if it's a little slow to load initially. I can go ahead and sign in, and I'll see my past searches. I can go ahead and hit the search button, and I can search across the patent data. For example, I can search for the word demo. I can sort by either the score that's provided by Azure Search or by the date of the patent. I can return 10, 20, or 30 results when I hit the submit button. This is making an API call to Azure and then performing the bag of words implementation on the patent titles and then doing LDA and HTTP topic modeling on the abstracts of the patents. We also provide the top-ranked related companies and the number of patents associated with the search that was performed. The search results are then provided along with the patent title, the score that Azure Search provides using TF-IDF weighting, the patent number, the number of claims, the patent date, the organization, the kind of patent, excuse me, the country, the state, and the city, along with the patent abstract. I'm also able to view my past searches, and finally, I'm able to sign out. This application, since it's housed within Azure, is not required to be installed locally. But instructions to run the application locally have been provided within the Git repository. We also have a detailed video of an extended version of this presentation out in YouTube. This video is approximately 30 minutes as it provides a demo of installing the application to run locally, which again, there's no need to do, but you certainly can. So we wanted to provide this as an additional resource. Essentially, what needs to occur is the repository needs to be cloned and the required libraries need to be installed. We found a great blog post regarding wheels for installing requirements. We had some major issues deploying this application out in Azure, and so we found this to be the best method. So that way we could install either locally or in Azure using the same repository. We also need to ensure that the stop words libraries are included for our application to run properly. So we've included a setup.py file that can be run and will download the required stop words and punkt files. Please note that the extended version of this presentation out on YouTube goes through these steps, but they are well documented out on the GitHub repository, so it should not be an issue. If you would like to drop or create the SQLite database that holds the user and past search information, you can run the runserver.py file to either drop or create the database. We'd like to also discuss how to use the software. The first step is to sign up. You'll need to create a username, provide an email, password, and password confirmation. We did use WT Forms validators, so if a username is already created or perhaps an invalid email address is provided, the application will provide notification that invalid information was entered when you try to create a user. When you go to create a user and you've successfully entered in information, you will then be asked to log in. After login, you will see that no searches have yet been performed by a particular user. If you would like to bypass this step, please feel free to use the user Z001 with the password of 123MEG. This will allow you to log into the application without creating your own user. Within the application, we can search across all of the fields that were entered into the SQL Server database and then joined through a view and then exposed through Azure Search. This information can be filtered by country, patent number, company kind. It can also be sorted by either the score or the patent date. We also have the ability to skip. So that means if I do a search and I get back 10 records, and suppose I want to see the 11th, I can go ahead and say skip 10 and return either 10, 20, or 30 to see the next set of results. This information was downloaded from the patentview.org website and used within our application. The search score is computed using statistical properties of the data and the query. Azure Search finds documents that include search terms in the query string, or some depending on the search mode. If you'd like to search on a specific multiple word phrase, please use quotes, and that will alter the search results that you get. This will favor documents that contain many instances of the search term. The search score goes up even higher if a term is rare across the data corpus, but common within the document. The basis for this approach, as we all well know from CS 410 Text Information Systems, TF-IDF weighting. Into the search field, we can go ahead and hit sewing machines in our text box and click submit. By doing so, will result in the top 10 records coming back for analysis. By default, the top 10 is from the score, but this can be altered to be by date of the patent creation. Note that by using the return count, up to 30 results can be viewed at a time. The word cloud with stop words removed is created from the patent titles. LDA and HTTP topic models are created based on the abstracts. Patent title is provided and followed by a table that returns key patent data information. The abstract is then provided for further analysis. If we go ahead and do another search on sewing machine and provide the country as US and hit submit, we'll see that the results are different. We can see on the right was our search previously. On the left is the search when we're using US. We'll see that the score is higher when we don't have a filter, but using our filter, our information, including the related companies and the patent numbers, is different since we filtered on US as the country. We can go ahead and say search again and enter sewing machine, enter a country of US, and sort by date. We'll see that the score is going to be much lower, but the patent date is much more recent as of 2017, August 8th. Doing another search, but using quotes around the word sewing machine, country of US, and sort by date, we can go ahead and hit submit. Doing so, we'll note that the sewing machine is required in the search, not just the word sewing or machine, but the date on the patent is from earlier in the year. Also note that the score is higher than was returned previously. We also have the ability to review past searches. This will allow researchers to share information and understand how their analysis has perhaps changed, or even to recall a good search that they have done in the past. To perform a use case example to test the software, we'd like to enter the minds of an R&D researcher using this application. So they would probably search for something along the lines of transmission electron microscopy, sort by date, and then go ahead and hit submit. This is where they'll gather insights and take action. The word cloud quickly provides insight into the patents established. The topic model will reveal keywords to explore for additional research, and key competitors in a field are revealed. Top patent abstracts are available for more detailed analysis. We would like to acknowledge that the data set was provided by patentsview.org. The word cloud D3 code initiated from the link followed below. However, it was altered as far as the font sizes and colors, etc., but it was a really good base for us starting our application. There's also a really great Pluralsight video on Python web application development that really served as a great foundation for our application. And then also we used HTML5 boiler templates from Initializer. As I mentioned, we use Wheels to do the install. We'd like to mention the blog post that sort of articulated that and made it possible for us to be able to deploy our application out into Azure. And Azure Search, the API, it doesn't have to be housed in a Python application, and it's really extensible into other applications or perhaps existing applications. So we just wanted to just highlight that it's really easy to make these API calls, and you can do it as simply as using something like Postman to go ahead and send an API call and get back a request very easily. We wanted to keep this video brief, and thank you so much for your time. I will just briefly come into the application and just show it to you, sort of a live running version of the application. So I'm going to go ahead and say I'll go ahead and sign in. I'll go ahead and log in. You can say keep me logged in. You don't have to. I'll go ahead and say sign in. I see my past searches. I can go ahead and search for information. Sewing machine, hit my submit button. see the information that comes back, the topic models that are established, the top ranking companies, and the search results, their scores, and the abstracts. I can go ahead, perform another search on sewing machine, and hit the submit button. Again, the word cloud is based on the titles of the patents. The LDA topic models and the HDP topic models are based on the abstracts for the patents. We've got our key competitors here and the number of patents associated with each of those organizations, and then the results. Again, we wanted to keep this video brief as per the information posted on Coursera, but we do have that detailed YouTube video for reference, and I can go ahead and actually go back to that slide to just show that one last time in case you'd like to see a more detailed version of this presentation. We thank you so much for your time, and we hope that you enjoy your Christmas break. Thank you so much.